Cougars. Okay, yesterday we were looking at two different properties. We looked at the associative property and the commutative property. And we were using them to create equivalent expressions and then simplify those equivalent expressions by combining things that were the same. Numbers with numbers, letters with letters. Today we're going to be learning a new property. This property is called the distributive property. And we want to see how can we use this distributive property to evaluate or solve equivalent expressions. So we know equivalent means the same with an equal sign, one side being equal to the other, and expressions being math sentences. So one math sentence being the same as the other math sentence. So we want to create these equivalent math sentences. And we're going to be using this distributive property to be able to do that. That is our learning target. In order to be able to do that, you should, by the end of 5.4, you should be able to, one, explain to me what is the distributive property. Tell me what it is. You should also be able to tell me how to use the distributive property to simplify expressions. How to simplify algebraic expressions with the distributive property. And then last, by the end of 5.4, you should be able to use the distributive property to combine like terms. So we have a couple things to do before you are ready to do all of those things. Okay, so first let's talk about what does the word distribute mean. So the word distribute is the base of distributive. Distribute means to share or to give out, to pass out. Distribute is sharing, and sharing means caring. So today we're going to learn that sharing means caring. So distribute, or the distributive property is all about giving. It's all about sharing. It's all about passing out equal amounts. So it is giving the same amount, and we're going to work with sharing. Okay, we're going to be creating this idea around equivalence, and you're going to use a lot of parentheses today. So be ready for parentheses. Okay, so distribute means to share, to give out. If I had papers to distribute, that means I'm passing them out to people evenly. If I had things to give away or to distribute to others, I'm handing them out evenly. Everybody's going to get the same amount of things. Okay, what does this mean in numbers? Okay, in numbers, let's see an example. So in numbers, I will have something that looks like this. I will have 3 groups of 7 plus 2. That is my numerical expression. So my numerical expression says 3 times 7 plus 2, or 3 groups of 7 plus 2. This means that 3 groups of 7 plus 2, or 3 times 7 plus 2, is the same as the distributive property. Or I can distribute that 3 into the parentheses. Now, I can say that this 3 can be shared with the first number here, which is a 7. I can say 3 times 7, or 3 groups of 7. The 3 is shared with the 7. I could also say I have another term, a 2, right? I have 3 groups of 2. So I have 3 groups of 2, or 3 times 2. Now I can simplify this expression. I know that 3 times 7 is 21, and I know that 3 times 2 is 6. 21 plus 6 gives me 27. So when I share my 3 with the terms that are listed inside the parentheses, I get an answer of 27 when I simplify. Now, if I want to check my work to see if my answers are equivalent, if this is equivalent to that, I could say 3 groups of 7 plus 2, and I could check it this way. I know that 7 plus 2 and 7 plus 2, there's another group, and 7 plus 2. 1 group, 2 groups, 3 groups. And now I can add those up and see if I get the same answer. I get 2, 4, 6, and then I get 21. 21 plus 6 gives me 27. That answer is the same as the answer that I got right here. So 3 groups of 7 plus 2 written this way is the same as writing it this way. They are equivalent. But that works because they're both numbers. Now, what happens when algebra takes over? Oh my goodness. What's going to happen when algebra happens? Let's find out. Okay, so we know that in the land of algebra, we know that algebra changes everything, right? Because algebra is numbers. So when we have algebra, we have A groups of B plus C. Right now, these are placeholders. So we can share the A with the B, and we can share the A with the C, just like we shared up here. We can do that. We cannot combine B and C. We can't add these together because B, we don't know what B is, and C, we don't know what C is. Those cannot go together. They don't have a value yet. They haven't been defined. So let's just do some sharing. Let's do some sharing. So we know we're going to have an A that's going to be shared. So we know it has to be shared with the B first. So A is going to share with B. A groups of B, or A times B. We know we're going to have A times C, or A groups of C. Nope, that's not a C. There we go. That's a C. Pretend that's a C. Okay, so we have A times C. Now, I cannot combine anything else because we don't know what anything else is. So I have to leave this alone, just like this. I can write it if I really, really wanted to. I could write it like this. I could write AB plus AC if I wanted to. It means the same thing. Or I could write A groups of B plus C, because that's what that means. But I don't know what B is and I don't know what C is, so we have to stop. We've shared, we've cared, and that's all that we can do for algebra right there. Okay, let's talk about what this looks like though when we actually have some numbers working with letters. Okay, let's do some real simplifying. So let's simplify algebra. So how do we simplify algebraic expressions? Let's figure this out so we can hit our second learning target. Let's talk about the distributive model so that we can do that. All right, so we have example A. Example A says 4 times n plus 5. Or I have 4 groups of n plus 5. Okay, that's what I have right there. I cannot combine n plus 5. N is a letter, 5 is a number. They are not the same. They may not go together. Apples, oranges. They may not go in the same fruit. They're not the same fruit. They cannot go together. Okay? So we want to put things that are the same together. So let's talk about what we're going to do. First, we want to care. So let's share. We're going to take we have one term here, and we have another term right here. So what we're going to do is we are going to share the 4 with both terms. I'm going to share my 4 with my n. And then I'm going to share my 4. So I get 4 times n, which is 4n. And then I'm going to share my 4 with the 5. I have to share it with both things. If there's 2 terms, I need 2 things out here. Otherwise, it's not equivalent. So I get 4 times 5. Now, if I do not put parentheses there, I just get 45, and we don't want 45. Now, I can combine. Well, we need to simplify. I have to simplify. So I can simplify this by saying 4 times n. 4 times n is 4n plus, what is 4 times 5? 4 times 5 is 20. That can be simplified. I can't combine those together because 4n is 4n, right? 4 groups of n. That's it. That's as far as those can go together. But this, I can put those together and get 20. We don't know what n is, so we're not going to do anything with it. There we go. That's what we have. 4n plus 20 is equal to 4 groups of n plus 5. Don't believe me? Let's check it. Shall we? Shall we see if we shared and cared enough? Let's do it. Okay, so we have 4 groups of n plus 5. Okay, there's one group. Here's another group. Here's another group. And our last group. Now let's add. Let's add them up. 5, 10, 15, 20. 1n, 2n, 3n, 4n. 4n plus 20. Oh my gosh, 4n plus 20. Woohoo! We shared. We cared. We didn't leave anybody out. We did it just right. Okay, let's do another example. Let's distribute again. All right, let's do another one. How about 12 groups of 2y minus 3? 12 groups of 2y minus 3. Okay, now what do? I share and care. Same thing. Okay, do it again. Start with how many terms do I have? I have 1 term, 2 terms. So I'm going to have 2 terms over here. Same thing, 2 arrows. 12 times 2y, 12 groups of 2y 12 groups of 2y minus 12 groups of 3. 12 groups of 3. Now we're going to combine what I can combine. I can combine the 12 and the 2 because they are both numbers. What is 12 groups of 2? Well, 12 groups of 2 is 24. 12 times 2 is 24. This tells me I have 24 y's. Why? I don't know. I don't know why we need 24 y's, but we have them. Minus 12 groups of 3. Well, 12 groups of 3 we know is 12 times 3, which gives us 36. This is simplified. Okay? It's simplified because this expression is equal to or the same as this expression. It's just that we've taken the number from the outside of the parentheses and we've put it into the middle. We've shared it. We've cared it. Okay? All right. Let's do a try it. It is your turn. Try it out. Let's see where you're at. Try it. Okay. I want you to do 7a plus 2. And I want you to do another one. Let's see if you can do this one as a challenge. 7 groups of 2 plus 6 minus 4d. Okay? Go ahead and try both of those. Hit pause so you don't hear me doing the lesson. Okay, so 7 times a is 7a. 7 times 2 is 14. So the equivalent expression is 7a plus 14. You could have also written it as 7 times a plus 7 times 2 first, and then simplified it to 7a plus 14. All right, next one. This one is a little bit trickier because I was challenging you. So I'm going to use 3 colors because there's 3 terms. There's a 2. There is a 6, which is our first term, our second term, and now I have a third term. So we're not only going to have one arrow of 7 times 2, you're not only going to have 2 arrows of a 7 times 6, you are now going to have 3 arrows. Yep, that's right. You had to share 3 times. So we subtract and we do 7 times 4d. All right. From there, you should be able to simplify this down. You could say 14 plus 42. Oops, wrong color. Minus, that is not a minus sign, 28d. I have a really bad headache. Okay, good. I did that right. I was like, wait, did I multiply that right? Sorry, guys. Okay, and then 4 plus 2 we know is 6, and that is 56 when we combine those, because those two numbers can go together. Numbers with numbers minus 28d. Okay, that is that. That one is simplified. That one is a challenge for those of you who love a good challenge. And go ahead and tell me, answer your essential question. How can I use the distributive property to evaluate equivalent expressions? And then rate yourself. Where are you? How are you feeling? 1, no clue what you're doing. Missing lender. Again, wackadoo, TV, that's you. 2, I understand, kind of, but I need more practice, and I also need to go to Google Meet and ask some questions. 3, I totally get this. I know that I'm just sharing, and I need to make sure that I'm paying attention to the terms. I'm also going to continue to practice. Go ahead, fill this out. When you're done, head on over, do your practice work, and make it a great day the Cougar way.